Hello, do you hear me?
Yeah.
Okay. Thank you very much, moderator, and good morning, everyone. I'm here to present my research, whose the title is Mapping Flooding Prone Area Using HP Fuzzy Method and Geospatial Analysis.
Can you put it on a full screen, your presentation?
Okay, no problem. Yes, please. Is it okay now?
Great.
Okay. So the case study is Grand Bassam. In introduction, we can say that from 1900 to 2006, flood in Africa killed nearly 20,000 people and also affected nearly 40 million more, which estimated about 4 billion USD, according to the Regional Office for Africa. We note also that flood is one of the most destructive natural disasters of climate change effect in West Africa, but mainly urban floods result from large impervious areas, inefficient sewer system, and are due to increase of urbanization. Flash flooding is one of the natural disasters that combine with climate change to create effect and cause some of the most destructive damage in Côte d'Ivoire. Statistical analysis showed that most of the coastal cities, for example, Abidjan, Grand Bassam, Grand Lao, etc., are flooding risk area, and besides, a total of 80,000 people are threatened by flooding in Abidjan, based on that source OSHA 2013. Last year, flooding in Grand Bassam killed 10 people with a lot of displacement and important family, according to the Disaster Risk Reduction Panel Secretary of Côte d'Ivoire. As you can see in the screen, this is some of the picture that show the problem. We have facing a lot of damage due to flooding during the rainy season. You can see a dead body, destruction of property. That showed that the importance of this problem that we are facing every year in the study areas. I'm coming now to present the study area Anomalies. Grand Bassam is a historical city that has been declared from World Heritage by UNESCO, and is a small town, but the population is around 74,000 and the surface areas covered 13 kilometers square. What about the data that has been used in this study? We have several data. We have satellite data, we have weather data, we have socioeconomic data, and auxiliary data that has been used to do this research. Here, I want to emphasize to present the framework from the fuzzy approach that has been developed, has been used in this study. The fuzzification is about to determine the universe of discourse. After that, you have to determine the language variable and also define the membership function from 0 to 1. After doing the fuzzification, now you have to do the fuzzy inference engine. That is about listing all inference rules. When you finish this step, you come to the diffusification. It is moving from a linguistic result to a numerical result. To summarize this, the fuzzy is a mathematical approach that has been combined to HP to conduct this research. Coming to the HP is a metric analysis approach that has been developed by one author that called Sati, and it divides the problem. Is normally to come to a complex problem to a more easy problem. So he has developed a lot of different steps to come down with the problem to better solve it. So this is a flowchart that has been developed and to present a summary of this method. The goal is flood risk. Everybody knows that. But to reach the goal, we need to define a criteria. So the criteria here is hazard and vulnerability. Under each criteria, there is some factor or indicator that has been considered in this study. For example, for hazard, we use the slope, consider the slope, the soil type, the rainfall, and drainage density, and we weighted them. For the vulnerability, we consider the land use and population density, and we combine them to get the vulnerability. And vulnerability will be also combined with hazard to now achieve the goal. So after develop the HP and combine with the FOSI, this is the different weight that we obtain from each parameter. So now we will multiply the weight for each factor and combine them to get now the HP FOSI hazard map. And in the same way, we also got the HP FOSI vulnerability map. After we combine them by considering the different percentage, because now vulnerability is due to human being activity is more important than hazard. So you can see that the weight is 0.75 for multiplied by vulnerability map plus 0.25 multiplied by hazard map. Now that will allow us to get now the flood risk map. What is the result of this research? You can see on top in A, B, C, D, this is a different map that has been elaborated based of what I explained earlier. So you can see the drainage density map, the slope map, the soil type map, and the rainfall map. And based on the previous slide where we show the weight for each factor, we multiply them and combine them using ArcGIS interface, and now we got the hazard map of Abidjan. You can see that for the major class, we have 24%, and high and very high classes cover 28%. What about the vulnerability map? The vulnerability map is a combination of population density map and land use map, and the results show that medium classes cover 35%, and high and very high covers 18% of the study areas. Now, after combining hazard and vulnerability map, now we got all the HP FOSI flood risk map of Grand Bassam, and this is the map of the this result. And summary, you can see that the major class covered 36%, and high and very high covered 28%. That means that if we want to consider, yes, medium is also an important area that you have to look at, because it's medium, that means that they can have a lot of damage also too. Considering these two, we have almost 74% of the study area that has under important and flooded areas. After developing this one, we went to a field mission to collect data for the flooded areas and for validation of this study. As you can see now, after plotting the flooded area point to the map that we got from our research, we realized that high classes cover 28%. That means that the flooded point combined to the high classes, we have 38%. When very high, we have 29%. And overall, we have 67% of the flooded area point that match with the class very high and high risk of flooding in Grand Bassam. That showed that this research can be used by decision making to undertake to prepare some better planning and land use to mitigate this problem in the study areas. As a conclusion, what can I say? You can see that major flood risk area in Grand Bassam cover 26%, and very high and high flood risk area in Grand Bassam cover 28%. And Grand Bassam cities and a flooded area with most of the quarter under high and very high risk zone. And HP FOSI and geoinformation technique based approach is a method that can be used to monitor flooding areas and implement floodplain management in urban areas. And there is a important policy needs to be taken and implemented in regard to the uncontrolled urbanization and illegally occupation of water drainage area to prevent more significant damage, because here in Abidjan, in Grand Bassam, there is a lot of uncontrolled urbanization, and because Grand Bassam is an urban area, our government need to take important and courageous decision to avoid every rainy season this kind of occurrence of flood in a different zone that has been defined in my presentation. That is the end of my presentation. Thank you very much to hear me. And in French, this is an overview of the place. It's a beach. It's a city around the beach. And in French, we say, merci pour votre attention. Thank you very much.
Merci aussi. Well, thanks. It looks like we have only two speakers connected. Oloyede, Mary Oloyede is not connected, right?
No, she's not here anymore. Now she's coming again.
She's coming again? Okay.
Maybe she have a network problem. Maybe she have a network problem.
Yeah. Mary, can you connect? Can you hear me? Can you put your presentation on the screen? What does D mean? Okay. Mary, can you hear me? Mary Oloyede? Doesn't look like she's.
Yes.
Okay. Can you put your presentation on the screen?
On the screen now.
Yeah, can you share your screen?
All right. Just a minute.
Doesn't work? Can try to do with mine.
Can you see now?
Yes, we can see.
Can you see my screen?
It's now Pasquale's screen, right?
Okay, you are not allowing me. I'm not allowed to share my screen.
Wait a second.
Pasquale, if you stop screen share first, she can try again.
Okay.
Yeah. Now please try again, Mary. Now we can see it.
Hello? Hello?
Sorry, you hear me? Okay, you can go ahead, Mary.
Can you see my screen now?
Yeah, we can see your screen. That's your screen, right? Yeah. Can everybody see the screen?
Yes.
Yes. Can you see my screen now?
Yes.
Yes, we do.
You can go ahead
All
with
right,
your.
so can I start?
Yes.
Yes.
All right. Thank you very much. I'm Oluede FM from Osun State University, Osogbo, Nigeria. I'm presenting our African orphan crops production, how viable economically. Orphan crops, they are also called the neglected crops or underutilized or understudied or under-researched crops. They are also called forgotten crops, lost crops. They are also called minor crops and crops for the future. Just like the popular crops, they are also categorized as cereals, legumes, root crops, fruit crops, vegetable spices, tree crops that are also orphans. Their importance have been used as food, as fodder for animal, for oil, both domestic and even the biodiesel. Then they are used in medicine. They cure a number of diseases. They are used in nutrition. If they compare favorably, even compared to the popular crops. Then economically, they also are used to generate income, especially when the popular crops they are in their off season. The two samples I'll be projecting today is they are pumpkin and snake tomato. Both of them, they are in Cucurbitaceae family of the plant family. The shoots of pumpkin, I will still show the pictures. The shoots, almost all the vegetative part of the pumpkin is actually used in Nigeria as food. The shoot is used as living vegetable portable. The young fruit is also used as vegetable. We call it kundu, as in Nigeria. Then the fruit of pumpkin orange cultivar is used as tomato or carrot. Can be eaten raw. Then the fruit of pumpkin green cultivar is used just as Irish potato. The seed is also used as just like melon, as a food tickling, soup tickling. Then the snake tomato, which is the second fruit, is used as alternative to the regular tomato. The quality from what I've researched and other researchers, notice what are projected. They have close to 30% protein, 20 to 30, depends on the parts. Then 80 to 90% antioxidant activities. Antioxidants, they are substances in fruits and vegetables that actually have the ability to arrest the pathogens that cause pathological diseases and the radicals that cause pathological diseases in the body. So, okay, phenolic compound, which also is part of component of antioxidants, these crops, they have them in abundance. The seed also have over 50% of fat. The seed have 60% omega-3 fatty acid, which is twice that of cod liver oil. And the pictures here, the first pictures is the pumpkin orange cultivar, which is used as an alternative to tomato in Nigeria. The seed is also there. All right. Then the green cultivar, which is the fruit is there, the porphyr, that's the shoot. Then the seed also is there, which is also used as a soup tickling. I move to the second picture, which is the snake tomato, Trichosanthus cucumerina. The vegetative part is there, and the pulp, when the fruit is ripe, can actually be fully ripened, the pulp, the fruits. All right, then the seed is inside the pulp when you open it, but both the pulp, both the fruit and the seed, sorry, both the fruit and the pulp, they are used together, just blend like that together with other ingredients for soup. So I have selected industrial potentials of pumpkin and snake tomato here. The first is bread flour supplement. The pumpkin, especially the green cultivar, has been used as a complement to the flour, to the regular flour that is used, the wheat flour that is used in bakery. So it can actually be used as such. The second potential that these crops have is the seed oil processing into biodiesel. This has actually been done successfully, and there's a need to find alternative to fossil fuel now, which is a trend in the world. And competing, when we compete with, when finding oil is competing with food that grains like maize are used for, there will be more trouble. So there's always a need to actually have an alternative to such grains that are used in finding the alternative to the fossil fuel. And these crops can actually, with the over 50% crude oil that have been found in each of these crops, I mean, they can actually be used successfully as alternative to this. So the third potential is the use of pumpkin peel as supplement to animal feeds. All right, as I've said earlier, maize, which is used mainly, which is as the major component of a feed, actually now is a major issue here in the developing world. So if you can find an alternative to maize, then that can ease out the pressure on the fuel crops that have been popularized and being cultivated. So the peel, because actually in the processing of the fruit of the pumpkin, the hard peel, when you remove it, it's something that can be dried and used as supplement to animal feed, or layer, whether it is layer ration or any feed. All right, the carbohydrate is high, which can actually be a substitute to the maize. Then the use of pumpkin seed in vegetable oil production also, we have found out that the oil in the seed can actually be used as a domestic oil successfully, and of course they are very rich in oleic and linoleic acid. Then the fifth use is the substitute of the regular tomato in paste making, and the pumpkin morpho type, the orange morpho type. Both of them, they are both used in the rural area by the rural women as alternative to snake tomato. So I said here there's a need to actually further research on this, on the appropriateness of in industry, the tomato canning industry. All right. So I go to perspectives. Majority of hungry and poor people live in developing countries. Often crops can play a major role in alleviating hunger, poverty, and nutritional problems in developing countries, most especially Africa if explored, especially in collaboration with relevant industry. There's a need to link industry actually with all these crops so that their potential can be explored. Then pumpkin and snake tomato are just 2 out of hundreds of such crops in Nigeria that can meet up with the challenges of poverty and insecurity in food and nutrition if properly channeled. Actually, most of these crops, they can meet up with the challenges of climate change. Especially pumpkin can stay at room temperature after harvest for six months without deteriorating. And we have checked what deteriorates actually in the nutrients after 6 months. For the first 4 months, everything is still intact. No significantly different in the nutrients after harvest and 4 months after harvest at room temperature. So this is one of the advantages that pumpkin actually has. Then conclusion, homogeneity in the global food supply is a menace to food security and economy. Over dependence on only a day's ahead, considering the adverse effects of climate change on crop production, which can wipe off a particular species of plant food, and has actually done so in a number of countries. So diversification to new crops, or at the least having alternatives to the over-cultivated ones, will without doubt be a relief or solution to the threat posed on crop production by climate change, pests, and diseases as well. I recommend, it is paramount that bringing the potentials of pumpkin and snake tomato to the relevant industry will encourage their commercial cultivation by the farmers until their industrial potential are actually brought to limelight. These crops may not really be fully maximized. So collaborative research is obviously non-negotiable on pumpkin and snake tomatoes, especially if we are going to industrialize them. So it is noteworthy that the conclusion and recommendation drawn here over the two crops that I've used as samples, all right, they are applicable to all of our crops in Nigeria and Africa. I have references here, and I thank you for listening. Thank you very much.
Thank you very much, Mr. Loyodi. I still see only one more speaker on.
Hello?
Yes. So I still see only one more speaker on the screen. So I'll give the floor to Ngongang.
All right.
Yes.
Mary, can you stop your screen share, please?
Trying to, okay.
Okay. Now choose.
Okay, we see it.
All right. Can you hear me very well? Hello?
Yes, we can hear you and we see it.
All right.
Right.
Hello, everyone. I'm Gongan Wanji, Daniel Piot. I'm from the Republic of Cameroon, currently based in Kenya. So I have a typical background in electrical engineering, more specifically in energy efficiency, basically. So currently I'm working with the United Nations Human Settlement Program as a junior expert in energy efficiency in the built environment, because Habitat has a scope, related to provide services to urban, basic services. So this presentation basically is being supervised by Dr. Kitio, who is my supervisor. Solid waste management is one of the most costly and complex urban basic services, and it's becoming a global and major threat to human beings and the natural environment. On a daily basis, the city of Nairobi produces over 3,200 tons of solid waste, which constitutes a great deal in terms of climate change. As a response to the problem, I will talk about an integrated resource recovery center, which is a waste to resource model that captures the value of the waste. My presentation is going to be actually outlined into 5 specific points. So the first point basically is going to, I'm going to have sort of overview of the main problem created by the poor waste management system, and then followed by the reason for the adoption of this model I'm going to present, specifically for municipality in developing countries. And then I'm going to present briefly the scope of the project in Gone site in Kenya. And then I will quickly go through the process of the composting plan that we are proposing in the case of this project. And then I will end my presentation by presenting the financial sustainability of the model, followed by the social and economic benefit. Next. Hello, if you don't hear me, please let me know so that I will have a feedback from the audience.
Okay.
All right. So now, yeah, we have the challenges created by the poor waste management system, basically across most developing countries, and more specifically in Kenya. So one of the main problem, or the first problem that we notice, is like there's this inadequacy between the economic growth and the urbanization. And also we have some sort of inadequacy of the people participation in the waste separation. The waste collection actually and the disposal are not consistent with the waste composition basically. So we also have a limitation in terms of the area for the landfill, because if you notice, because of the lack of waste management system, most of the area that are used basically for the landfill. So as the waste generation goes higher, we have a lack of space to provide for such services. And the budget for solid waste management increases over the time because the budget actually is directly related to the waste generation. And also this sort of imbalance in terms of the cost of the waste management. And to end up in terms of the problem, we also have a lack of regulation to support, the waste reduction at the source. Now, why are we proposing the Integrated Resource Recovery Center? Why is it different from other technology or other solution? Because this specific model actually treats a large amount of waste and also creates some sort of economic opportunity from waste to resources management. It also improves the community participation in the separation of the waste, and also use some sort of low cost and labor intensive technology for the poor. So in short, we think this specific model is more appropriate, for the municipality and also, small town that actually have a lot of challenges to deal with the waste. And to close this aspect, we think this model actually provides some sort of private, public, and community partnership, whereby the people, actually the municipality, the people actually are set at the heart of the process of the waste, basically. So, as I said, the project location actually is based in Kenya, and as you can see from the map, the project is located at the dump site near the Gong Hill, approximately 25 kilometers southwest of Nairobi. So this public site is managed by the city council of a city called Kajiado, a town called Kajiado, and receive on daily basis around 60,000 tons. Now, the Gondom site mainly receive waste from Nairobi and other local community, as you will see in the next slide. Now, the dump site basically is operating in the absence of safety guideline, safety guideline and standard, and also lack of waste treatment, posing a serious health and environmental hazard. So the Kenyan government ordered the closure of that dumping site as it failed to meet the environmental standard. So the current situation has prompted the city council of Kajiado to put sustainable solid waste management as a top priority. So prior to, so like I was saying, the actual site where we're having actually received waste waste from different sources, from different locations. Here we have Ngong, we have Ungai, we have Kiserian, and then we also have Nairobi area, into bracket Langata. So you can see the percentage of all the incoming waste actually dumped in that site. And then based on the initial study that was done, we noticed like approximately 70% of the waste is basically organic. So prior to the closure of that dump site, the government actually proposed, or actually we have some sort of collaboration with the government Kenya to see what could we do in order to propose some sort of alternative while the process of closing the site is undergoing. That is actually the main purpose of this solution that they're proposing today. So this is the map of the new site and the surrounding. As you can see, this is actually where the site is being located. And then, as I was saying, this is the site layout of the integrated solid waste management. But now, the Integrated Resource Recovery Center is actually what you see here in red. because actually there was a project to build a sort of a permanent structure. But since the time frame to build that structure was quite a bit longer, so we proposed actually to have this traditional system whereby as the main structure is being constructed, this system can actually serve to relocate people that were used on the former site, to keep processing the incoming waste coming to the dump site. So the Integrated Resource Recovery Center has some sort of advantage because based on the incoming waste of 60 tons, there's a possibility to process 18 tons to transform the 18 tons of organic waste into compost, and 18 tons as well to produce the biogas. Then out of that 18 tons, which consists basically of the aluminum, the plastic, the glass, the steel, and thing, basically the recycling material actually can also be recovered through that model. Then we could have around 6 tons, which is the rejected material that could actually go to the landfill. So this is actually the model, this is the design that we actually propose, in terms of providing our solution. As you can see, we are going to actually go into detail of each of the different part of the system. But the layout is being organized into 7 specific sections, as you can see. But you will just basically focus on which section actually is being important, for the sake of recycling the waste. So the first section basically is what we call the tipping area. So this is the area whereby, it receives on daily basis all the waste coming from the different sites. So the number of people working in that area was approximately designed to be 150 people. So the basic idea of this tipping area is just to receive all the incoming waste that will come to the facility. So then we have the sorting area, which is actually very, 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 very important. So we actually propose in our model to see how we can make use of the 150 people to actually undertake the sorting activity in a very consistent way. Do not forget, the basic idea of undertaking this activity is to be able to, to bring aside the recycling material, and also to be able to bring out the organic waste and, undertaking a sorting activity in a very efficient way. So based on that, if you have 150 workers in that particular facility, all of them will actually, but on daily basis, work around 400 kg of incoming waste per day. So also we also thought of providing some sort of machine, shredding machine, cutting, and also in the storage area. And then the number of skilled technicians operating the shredding and the cutting machine are actually thought to be 2. And the other 2 are for packaging and the transport to the storage area, therefore making total number of workers to be 4. And come back to this particular point, we think, the shredding machine basically just to be able to reduce the weight of either the plastic, of all the recycling waste that you might have actually in the system. So then you have what we call the composting area. So the composting area actually consists of some sort of box. But now those different boxes are not just normal box, but they are now supposed to actually be the main component to process the organic waste in order to obtain a good quality of compost. So you will see close to my side some sort of basic calculation that we make in order to know exactly what could be the required size that could contain 18 tons of organic waste on after some time, depending on the rate at which the waste are being processed in the center. So I don't want to go deeper into the science of composting, but actually our model took into account the maximum days that could be required for an organic waste to be processed in order to obtain a very good quality of compost. If you have any question in terms of the design calculation that we made to obtain the required size of the box, so we can discuss on that later on. So Also, as I said, one area actually dedicated is the installation of the biogas plant. So, as I said initially, this model is not that quite new because in some part of Asia, especially in Sri Lanka and India, the system has been used before. So, sorry. Okay, so this is the landfill area, as I was saying, where only 10% actually goes to the landfill in terms of what is being recycled. And yeah, so that's that. And also we provided, to use the rooftop of our system, of our center to install the solar panel. Then also we did some sort of calculation on that to actually know the size of the whole system. So I will not go through all this. I will just quickly jump to actually have a look at the different expenses, because we believe like this system actually is financially viable and financially sustainable, because we have a lot of income that could be generated by operating such model. And we also think that there are a lot of social benefit that comes along this model, like better job opportunity, improved living condition, and it also reduce, the disease incidence and the better environmental awareness. So in conclusion, we think, in order to have a successful implementation of this model, the local government really need to be involved, and also the citizen, in order to actually bring more awareness on the possibility and different resources that could be generated out of, the organic waste processing. Thank you very much for listening.
Thank you very much. Well, we are well within the time, and there still are only the participants who have already presented, so we can have some general discussion, and if somebody joins later, maybe he can give the presentation. But at this point, we can discuss